In sections 3.6 and 3.7, we use what we learned from implicit differentiation to find derivatives for the inverse trig functions and for the logarithmic functions. Before we get to that, we have to remember what it means for a function to be one-to-one, or if a function is not one-to-one, then that means its inverse is not a function. So let's consider the function sine of x, which you can see graphed here. Is this function one-to-one? In fact, it's not. Okay, and there's a few different ways that you could understand that or see it. So if a function is one-to-one, then it can't have any inputs that get mapped to the same output. So again, that's not the same as being a function. To be something could be a function, but not be one-to-one. So, for example, here, the inputs x equals 0 and x equal pi get mapped to the same output, which is 0. Okay, so that's a way to show that this function is not one-to-one. We could also consider, for example, the inputs of pi over 4 and 3 pi over 4. I mean, these are not the only examples, but those both get mapped to the same output. And I don't know, again, how much you remember your trig. But the sine of pi over 4 and the sine of 3 pi over 4 are both the same, 1 over radical 2, or you might have learned them in school as root 2 over 2. So, in other words, if we set up a table of values, and we just put a few x's in here, let's say 0, pi over 4, pi over 2, 3 pi over 4, and pi. The sign of 0 is 0. You can, perhaps you know this from the unit circle definition. You can look at the graph above. The sign of pi over 4 is 1 over radical 2. The sign of pi over 2 is 1. The sign of 3 pi over 2 is 1 over root 2. And the sign of pi is 0. Now, y equals sine of x is a function. In other words, any x that you give me, such as the ones in this table or any others, there's only one y that goes with that. However, if to get to the inverse, we swap the ordered pairs, and we make a table of values for y versus x, and we have inputs now that are y values. So again, to get from a function to its inverse, I swap all the ordered pairs. Now, I have an issue. Because if somebody tells me, okay, my input is 0, I don't know whether to tell them the output is 0 or the output is pi. Okay, so again, just by way of recall, in order to be a function, each input can be mapped to only one unique output. Okay, but in this case, again, using the table of values on the right, which is for the inverse, the input 0 is mapped to two different outputs in this table. Zero and pi. All right, so I'm talking about the inverse. And the input 1 over root 2, if somebody said, okay, my input is 1 over root 2, what's the output? I'm not sure what to tell them, because that input, at least even in this table, and we could expand on this actually, but that input of y equals 1 over root 2 is getting mapped to two different outputs, pi over 4 and 3 pi over 4. So if somebody says my input is 1 over root 2, what's the output? I'm not really sure what to say. So buttons up your undershirt, this inverse is not a function. Now earlier you might have been thinking of another way to see this. That is, y equals sine of x fails the horizontal line test, which I will abbreviate HLT. In other words, when we look back at the graph, a horizontal line, and let me try to draw the one up here, that corresponds to the pi over 4 and the 3 pi over 4. Wasn't quite in the right place, but pretend. All right, that means those two inputs get mapped to the same output on the original function, which means when I look at the inverse, that y value of 1 over root 2 becomes my input, and that is then getting mapped to two different outputs, which means that inverse is not a function.